Okay, so here's problem number 2. We're going to find the absolute maximum and minimum. Um, so, okay, so the first thing, let me move all this stuff so that I have enough room for both. Okay, so let's do this guy. So we're going to find the derivative first. Let me do it right here. So the derivative of this guy is going to be negative 2 sine x and then plus 2 cosine x. Oh. 2x, sorry. Okay. So that's the derivative, and so we set this guy equal to 0. And solve it. So we have, let's bring this guy over. So basically what we have is if we move the 2 sine x, we're going to get cosine x equals to, again, cosine of 2x equals to sine of x. Okay, so then you want to know, okay, what angles does cosine of 2x equal to sine of x? And so if you think about the unit circle, you think of your known values. So if you take a look here at pi over 6, sine of pi over 6 is going to equal to 1/2. And then cosine, this would be cosine of not pi over 6, but actually cosine of, in this case, this would be 2 pi over 6 or pi over 3. And so this is actually going to equal to, well, cosine of pi over 3, that's also equal to 1/2. And so then what that means is that you have a critical point here. A critical point of pi over 6. And if you check pi over 4 and pi over 3, they don't work. And those are the only ones you have to check because we're only going from 0 to pi over 2. So then, since we're looking for the absolute maximum, well then we're just going to plug all those guys, those 3, into the original function and compare. So we're going to compare the value of the function at 0, the value of the function at pi over 6, and the value of the function at pi over 2. Okay, so if you plug 0 into the original, you get 2 cosine of 0 plus sine of 0, which equals to 2. If you plug in pi over 6, you get 2 cosine of pi over 6 plus sine of pi over 6. Oh, 2 pi over 6. Jeez, I need to stop doing that. Okay, so cosine of pi over 6 is root 3 over 2, so this is square root of 3. And then plus, this is sine of pi over 3, essentially, so this is another root 3 over 2. Okay, and then pi over 2, so this is going to be, well, let me approximate this guy. If you approximate this guy with a calculator, this would be about let's do 2.6. And then 2 cosine of pi over 2 plus sine of 2 pi over 2. And this is just equal to 0. So what we've got here then is our absolute minimum, which is this guy. And then we've got our absolute maximum, which is this guy. And that's it. Okay, so now let's try this guy. So give me a second here. So let's erase this guy. Okay. So the same thing for this guy. We're going to find the derivative first. So the derivative of this guy is 1 minus 1 over x. And we set it equal to 0 again. And so we have a critical point at 0, but obviously doesn't exist there. So we are going to solve it. So if we multiply through by x on both sides, what we get is x minus 1 is equal to 0. So x equals to 1 is my critical point. I don't know why I wrote 0 there. Sorry about that. Okay, so this is my one and only critical point, and it is in between 1/2 and 2, so that's good. And so now I'm going to test these points. So I'm going to plug them all into the original 1/2. I'm going to plug in 1, and then I'm going to plug in 2. Okay, so I've got, if I plug in 1/2, I get 1/2 minus ln of 1/2, and this is equal to about 1.19. If I plug in 1, I get 1 minus ln of 1, which is just 1. And if I plug in 2, I get 1 minus ln of 2. Sorry. 2 minus ln of 2, which is about 1.3. Let's round it off to 1. So then I've got my absolute minimum and my absolute maximum right here. And that's it.